studies the electrical explosion of conductors is in current scanning mode is one on the key issues of the energy transpiration efficiency along vacuum lanes in high power pulse generators. Such generators may be used for different technical applications. For example, the implementation of controlled thermonuclear fusion schemes based on the pinches. The main problem of these generators is a possible electrical explosion of the transmission lines electrode surfaces. During the electrical explosion, the low temperature plasma formed on the conductor surface, and the shock wave and the wave of nonlinear diffusion of magnetic field propagate into the conductor surface. And FT instabilities and overheated instabilities can be developed in the metal. In our previous work, we cylindrical conductors of different types were studied. The parameters of these conductors you can see here on this slide. As usual, we have two configurations: the solid or hollow cylindrical configuration. And the main from this point of view of study on nonlinear diffusion and surface plasma formation, it is of interest of study a flat conductor. A flat conductors designed in such a way that the induction of a magnetic field and at their surface is approximately equal the induction of magnetic field on the surface on cylindrical conductor. To solve this problem, the width of the flat conductor should be approximately of this. And according to estimates, the parameters of our flat conductor should be this. The length 10 millimeters, and the thickness of flat conductors was about this 100 or 200 microns. And in this configuration, the magnetic field induction reaches the net value only in the inner part of the flat conductors. The characteristic feature of flat conductors is significant enhancement of the magnetic field at the edges of the plate. The plate compares the magnetic field in the center of the plate. The disadvantages of this configuration are the use impossibility of the X-ray transmission technique, the high probability of uncontrolled filling in the gap by the expanding plasma, and the significant complication of modeling the magnetic field distribution. Investigation of the skin explosion of flat conductors in the symmetrical configuration electrode is of interest. Here about flat conductor design such a way. The induction of magnetic field is a Wolf surface. The Wolf surface of flat conductor is approximately equal to the induction of magnetic field on the surface of cylindrical conductor. And on the slide you can see the big generator parameters and diagnostic complex. The parameters of big generator is the current is about 2.5 milliamps, and the current rise time about 100 nanosecond. One of the main diagnostic instrument is a full-frame optical camera H6 physics position of 3 nanoseconds for every frame. And the load assembly are shown here, and the parameters of flat conductor which used in the experiments you can see here. And this is a both side of our work. Using the HFC-Pro optical camera, front and side image of the load will be obtained in experiment. This is the front images and the side images. The big glow of the plasma channel strip is observed on this nanosecond, on the beginning of the current path. And on this nanosecond, it becomes more observable and begin around the hole. This is the drop hole. The appearance and development and stabilities of the edges of the flat conductor clearly seen. It's here as the front images and here in the side images. But the edges of our flat conductor is glow intensively. That's the center of our plate. The two-dimensional MHD code was used to simulate the explosion of flat conductor. In this code, the simulation of explosion process is performed in the XY geometry. Current flow in the direction of the z-axis, which is perpendicular in the image plane. The new code is based on algorithm was used the two-dimensional MHD code Euler earlier. And the system of hydrodynamic equations used in the code consists of the law of conservation for mass and momentum and energy. And the magnetic field induction was calculation using this law. The explosion of flat conductor was simulated using this condition. And we use a real experimental current waveform and the flat conductor parameters I can see here. And this is the distribution of the initial distribution of density. This figure shows the distribution of the density and temperature on this moment. And the temperature of the most part of the conductor is about 20-30 electron volts and somehow the thermal velocity of the ions is about this value. Plasma expands with the speed close to ion thermal velocity. The size of the conductor along the x-axis particularly does not change during the electrical explosion, and it observed in the simulation as of experiments. The conductor expansion occurs only along the y-axis only. This phenomenon could be explained by the magnetic field enhancement on the edges of the flat conductor. This expression for enhancement factor is shown here, and hence the magnetic pressure at the edge of conductor is approximately 3.2 times more than the pressure in the center of our plate. You can see this here. You can see a simulation. You can see simulated enhancement of magnetic field at the edges of conductor. The enhancement of magnetic field at the edges of conductor leads to expansion of the plasma along y-axis. While the expansion along the x-axis is suppressed. And conclusion: the appearance of plasma channel and the axial region of the flat conductor, as well as the appearance of different instabilities on its surface, was recorded with both configuration of the electrode, the symmetrical and asymmetrical. Especially developed two-dimensional MHD code was used to simulate the explosion of flat conductor in symmetrical electric configuration. The MHD simulation showed that during of explosion strong magnetic fields of flat conductor, whose width along the x-axis is much greater than the thickness along the y-axis. The plasma expands along the y-axis, while expansion along the x-axis is suppressed. Possible explanation of expansion of that, the enhancement of magnetic field at the edges of the plate provides high magnetic pressure at the edges of the plate as compared to magnetic pressure in the center. The simulation results are good agreement with the experimental result obtained. Thank you for your attention.